In this video lesson, we are going to cover the second part of tangents, which is covering inverse tangent. Now, if you remember in lesson 1, we talked about the tangent ratio. Okay, we used the tangent ratio and the tangent button to find an angle, to find the ratio when you were given an angle. So we could use tangent if we're given an angle and a side to find another side. Or we could just find the ratio if you are given the angle. Now, the inverse tangent is if you're given a ratio, then it will help you find the angle. So remember, we used just the tangent button yesterday, right? We would put tangent and then put the angle in, and it would give us the ratio. For inverse tangent, if you notice up here above tangent, it says tangent, and then it has to the -1. Okay, anytime you see to the -1, that's talking about the inverse. We're talking about the opposite. So what you have to do is push the second button and then push the tangent, and then if you look up here, it says tangent to the -1, which is the inverse tangent. So if you're going to use this one, okay, the -1, you have to put a ratio in here, okay? So that's the difference. If you hit tangent, you have to put an angle in. If you hit tangent to the -1, you have to put in a ratio. So for example, this says, what would be the angle for which the tangent ratio is 2? So what you would do is you would go to your calculator, and one thing that we want to remember is whenever you open your calculator up, you want to go to mode. You want to make sure that it's in degree mode. Okay, we talked about that last time, but that's really important. If you leave it in radians, you're going to get a wrong answer. So here it says, what would be the angle for which the tangent ratio is 2? So they've given us a ratio and we want to find the angle. So that means that we have to use inverse tangent. So here, if you notice, I have tangent -1. So I put in 2, and that gives me 63.43. So that would tell me, so then my answer for this one would be 63.43 degrees. All right, this one wants to know what is the measure of angle P. All right, so we want to know the measure of angle P. Now remember, for a tangent, right, for tangent ratio, okay, so the tangent of angle P is going to be opposite, okay, so that would be 11. It's opposite over adjacent. All right, so remember, when we're talking about adjacent, we are not talking about the hypotenuse. All right, the adjacent is the side that is next to the angle, but it's not the hypotenuse. So the adjacent side then is going to be 8. All right, so since we're given a ratio, in order to find this angle right here, we're going to put in our calculators the inverse tangent, and we could do two different things right here. We could take just 11 over 8. You can just leave it that way, and that would be the way that I would suggest doing it. So you could leave it as 11 over 8. Or if you want, you can convert it into a decimal. 11 over 8 is 1.375. So I'll show you here that it'll give us both the same answers no matter what we put in. Okay, so here I put inverse tangent, so we can put 11 over 8. Okay, so that's 53.9, which we'll go ahead and round that up to 54. So we'll say angle P is 54 degrees. Or if you were to put the decimal in there, 1.375, I'm going to end up with the exact same answer because 11 over 8 is exactly 1.375. There's no more decimals after that. So if you look, you get the same exact answer. So either one is fine. You can use either one. So angle P then is going to be 54 degrees. Okay, this one wants to know what is the measure of angle P. Okay, so the same thing right here. We're going to do the same exact thing. So we have angle P. Oh, let me change my pen color since that one's. So here we have angle P. All right, so remember the tangent of angle P is going to be opposite, that's 3, over the adjacent side. So that would be 4. Okay, so here we can put the tangent, right, inverse tangent 3 over 4, and that's going to give me my angle. Or we can put tangent angle 0.75. So either one of those are going to give us the right answer. So here we're going to say tangent 3 over 4. So that's going to give us 36.86, and just depends on how they want you to round your answer, you know. So, and then if I could put 0.75 in as well, and I'm going to get the exact same answer. Okay, now on this one, this says find the measure of angle TSU to the nearest whole degree. Okay, so they want us to round it to the nearest whole degree. Okay, angle TSU. Now, if we look, we have the hypotenuse is 6.1, all right? And so far, that's the only thing that we have. So what we kind of have to do is remember some of our theorems from the last unit. If we notice here, we have a chord, right, or a secant line, because it is touching the circle at 2 spots. Okay, so we have this secant line, and it's intersecting this radius at 90 degrees. Okay, so our theorem that we had earlier is when we have a chord that intersects a radius at 90 degrees, we know that it bisects that chord. So if UV is 5, we know that TU is 5. So this right here is going to be 5 centimeters. All right, so that gives us that angle. Now, in order to find angle S, right, we need opposite over adjacent. Okay, so the opposite is going to be 5, but we still don't have this adjacent angle. We don't have SU. Okay, we know that this is 2, that UW is 2, but we don't know what the radius is, so that doesn't, the 2 doesn't really help us. Now, what we can do, if we notice here, we have a right triangle. So what I could do is use Pythagorean theorem to solve for that missing side, right? So I have a squared, we'll leave that one blank, and then b squared we can put 5 in. So we have 5 squared, and then we have 6.1 squared. So now we have a squared, and then we are going to take 5 squared, which is going to be 25. And then we're going to take 6 squared, which is 37.21. And then we're going to minus 25 from both sides. So minus 25 from 37.21, which is 12.21. And then you want to take the square root of that, which is going to give you around 3.5. So A, okay, so this side is going to be approximately 3.5. So now I can find angle TSU by putting opposite over adjacent, right? The tangent of angle S is going to equal 5 over 3.5. So now, since I have the ratio, I can use inverse tangent. I can say the tangent, right, the inverse tangent of 5 over 3.5 is going to give me the angle. So now that's all I have to do is put in my inverse tangent. So here I'll say inverse tangent of 5 over 3.5. And that's going to give me 55 degrees. So I know that the measure of angle S is 55 degrees. And then from there, if they wanted angle T, right, we could just say 55 plus 90 and then subtract that from 180. All right, for this one, they want to find the measure of angle K. All right, so remember, the tangent of angle K is going to equal opposite, so that would be 21, over adjacent. Okay, so it's the leg that's next to K, because here we have 21 and 20. Okay, so here the adjacent side then is going to be 20. Okay, so I have 20 right there. So what we could say then is that inverse tangent of 21 over 20 is going to give us that angle. All right, so we'll go put that into our calculator. and that's going to give us an angle of 46.4. We'll just say 46.4. So we can say angle K is 46.4. This one says to write an expression to help you find the measure of angle N. So it doesn't even want us to find the measure of angle N. It just wants us to find write an expression. So we know that the tangent of angle N is going to equal opposite over adjacent. Okay, so angle N, we have opposite, which is 6, and then adjacent, which is going to be 7. All right. Now, since we have the ratio, but not the angle, we have to use the inverse tangent. So we say the inverse tangent of 6 over 7 is going to equal angle N. So that would be the expression. And then if they wanted you to find angle N, you could just go plug it in. And once again, okay, this is just a last reminder, make sure that whenever you go, when you turn your calculator on, right, hit mode, and then you want to arrow over to degree, okay, and hit enter, okay, you have to have it in degree mode. And that's the end of tangents part 2.